how to know when to add or subtract or what function to do. It's really not just about whether or not how to know when to go add or subtract. It's really how do you get rid of something that you're trying to get rid of. And this rule applies for all add, subtract, multiply, and divide. You say, what's my goal? My goal is to get rid of this 1. What is the 1 doing? Well, it's in the problem, it's being added. It also means that it is a positive 1. We can also look at it that way, but the operation that's of add, subtract, multiply, and divide, for add, subtract, multiply, and divide, we know that add and subtract are opposites of each other, and we know multiplication and division are opposites of each other. So you always do the opposite of whatever's happening in the problem if you want to get rid of something. Because my goal is to get u alone on one side of this equal sign. So I'm going to have to get rid of the 14 and the 1. And in order to get rid of the 1, because we always get rid of the number that's attached to the letter last. Sorry about my dogs back there. We're going to get rid of the 1, and it's currently being added. And in order to get rid of it, we have to do the opposite. So we're going to subtract 1, and everything we do, we have to do on both sides of the equal sign. So that means we're also going to subtract over here. I even write it this so my eye can visually see I'm doing exactly the same thing on both sides. So then what we have here is this, because this needed to become 0, needed to cancel out. Positive 1 and negative 1 cancel out, or plus 1 and minus 1 cancel out. So now what we have left is 2 is equal to 14u. Well, now what's happening between the u and the 14, the operation of add, subtract, multiply, divide, it's being multiplied. So to get rid of the 14, we have to do the opposite, divide. So we're going to divide by 14 here, divide by 14 here. And so 2 over 14, we also call that 1 over 7 if you reduce it. Here's another example. I want to get x alone. That's always the goal, get the letter alone. I got to get rid of the 9 and the minus 5, or the 9 and the negative 5. And we're going to get rid of the 9 last because it's attached to the letter. So here, we're going to get rid of the 5 first. The 12's not affecting us because it's on the other side of the equal sign. And again, our goal is to make this so the x is by itself. Like over here, we had the u by itself on this side. It doesn't matter which side, just get it by itself. And so here, we're going to get rid of the 5. Since it's being subtracted, we're going to add it. And we have, now we're going to make sure we do it on both sides. So that cancels this out. We have 9x. And then we have negative 12 plus 5, which is negative 7. And again, to get the x alone, we're going to now divide by 9 on both sides. Because it's currently being multiplied by 9, so we're going to do the opposite, divide by 9. And so negative 7/9. And one last one, if you have 10x plus 4 equals 16. Then, again, we want to get the letter alone. So we're going to get rid of this 4. It's being added right now, so we'll subtract it from both sides. And then I'm going to do another problem in a minute that kind of shows something slightly different so you can see another scenario. So we'll divide by 10 on both sides. And so we get 12 over 10. And in algebra, we don't put that as a mixed number. We just reduce it as far as we can. So both of those can be divided by 2, so we'll call it 6 over 5. I think one of the ways I wanted to show you was like if this says 5 plus 2x equals 8. Again, we want to get the letter alone, so we got to get rid of the 5. Right now, this is a positive 5 because there's no sign out here, right? This is a positive 5. And if you have a positive balance in your checking account and you want to bring it to 0, you want it to go away, you're going to subtract it. So it's the same as what we did on these other problems. We just don't see the plus sign out here, but it's basically being added if it's a positive like this. So we're going to subtract 5 from both sides. So we have 2x equals 3. And then divide by 2. So I think that part you're pretty good with, in multiplication and division. Likely, most people are. If you have negative 3 minus 4x equals 18. Well, this is a negative 3. We want it to go away. We could call it minus 3. And so in order to make it go away, we're going to add 3, because that's what it's doing in the problem. It's being added or subtracted. Up here, the 5 was positive. It was being added because of the positive here, not because of the plus here. This plus up here belonged to the 2x. it's the 4 is what's being subtracted here. The subtraction belongs to the 4, or negative belongs to the 4. So it's the sign that's out in front of the number that tells you what's happening. And so we have plus to get rid of that, so we'll add here. So we have negative 4x equals 21, and then divide by negative 4. Because this is a negative 4 or a minus 4, but it's the action that's happening between these two, where we want to break the bond that these two have, is that they're bumped up against each other. So it's being negative 4 times x. So to break that bond of multiplication, we have to do division. So then we have x is negative 21 over 4.